Hi everyone, welcome to the review for section 2 of this tutorial series. Kind of lied in the introduction. You're also seeing this in the review, because it was during the review and introduction recordings I caught the mistake. I don't know how it worked in the original files, because I'm not actually getting those errors there, but honestly having less convoluted code is slightly better. If you're not sure what I mean by convoluted code, then I successfully was able to edit out me putting in some very convoluted code and was able to edit in the correct way to do our stacking system and our weight system as well. So in this section, we created our inventory menus. We created a automatic pickup system. We created a harvestable pickup system with stackable items. We created an ability to use our items to get pop-up displays, which don't work when you have a menu open, to discard items, to discard singular items, to split stacks. And we did a lot of work to do all of this. So let's take a quick review on everything that we've done. So let's start with our item setup, because that's a little bit easier. We have our item master, which we now use to check at start, are there any items that the item actually has? So what I mean by this is when we place an item in the world, well, this capsule might represent, in this case, 26 herbs. Whereas this capsule all the way over here represent 1 herb. We check, is that value at least 1? If it isn't, then the item shouldn't exist and we destroy it. To double check this on our pickup event, we make sure that the amount is still at least 1. If it isn't, then we don't do the pickup. So when we overlap with the item, we check, is it the player overlapping? We do this without casting. If it is the player overlapping, then we check. And this, for some reason, this bug actually didn't show up in this recording. However, in the original recordings, it did. So if you had that bug, hopefully this fixed it, because it definitely did in my earlier recordings. So what we do is we check, is the player already overlapping? If they are not already overlapping, then we check, is the player actually looking at the item? And we do so by using a line trace. I almost did not open that up, so that I could do good abstraction. Now, we do this by ignoring the player, but making sure we're not ignoring self, because this is taking place in the item, so we don't want to ignore self, but we do want to ignore the player. If the player is able to see the item, so the player is looking at the item, then we will trigger an event in our character that causes that prompt to come up saying, we set the player to overlapping. We double check that they are set to overlapping, and then we trigger the prompt, which is actually we trigger the overlap event, not the prompt. I keep saying prompt, that's wrong. What we then do is the overlap event. We check, is this a harvestable item? Do we need to press something to pick it up? If we do, then we have the prompt. If not, we automatically pick the item up. If the player hits the prompt to pick the item up, we check once again, as I said, is there something to pick up? If there isn't, nope, we are done. We set overlapping to false. We abort the overlap, which we'll talk about in a moment. If there is something to pick up, then we run our pickup event. And we do this through our item master. So we have this long little check of getting the item master to run the event, making sure the inventory is valid, and then making sure that there aren't more items to pick up. Now, the reason for this is in section 4 of this tutorial, when we actually put our trees into our world, we will have trees that have a base amount of 10, but we can only pick up 5 branches at a time. So we are going to destroy the actor after a minimum of 2 harvests. Actually, the base might be smaller than 10 depending on, or the amount might be smaller than 10 depending on the size of the tree, but we'll talk about that later. Let's assume the trees are a minimum of 10. It means a minimum of 2 harvests. So the amount remaining will be 0 because we picked up the max we can pick up. But there's still more in the world. So we check, is there more that can be picked up? And if so, well, then we leave the item in the world, but we change the amount it has to add. If we've picked up everything possible, then we set the actor to be destroyed. If the actor is set to be destroyed, then all we do is we re-trigger the overlap. And why we pass through self here is to make sure that the player isn't seeing the item that it's just picked up as a re-trigger. And the reason why for re-triggers, notice that these two are really close together. These two are really close together. All of them are really close together. The player is standing here. I'm in 2 overlap trigger areas. I might want to pick up multiple items. We then destroy the actor that we've picked up. Again, this is why we want to pass this through to the player. We want to say ignore this item. And then we set our is overlapping to false, which means that when we come back through here, we can reset everything easily, because that's where we come back to the retrigger. When we either pick up an item or walk away from an item, I mentioned that we probably should include the confirms player, but we didn't. That'll be something I'll include in the next section. We check, is the player overlapping and is it harvestable? In other words, is there a prompt on screen? If there's a prompt on screen, then we remove the prompt. If the item is something we shouldn't be able to pick up, we remove the prompt. So, really, the abort never should happen. That is just in case something goes horribly, horribly wrong. Then we have an override event for what happens when we use or consume an item. So for our eating, it changes our health, and we destroy the item. So I say destroy because we have to spawn in the item from our inventory to use it. So we created child classes of equipment, resources, utility. We'll focus on resources. Resource master has in its construction script a setting that checks, was the item discarded? If it was, we're going to spawn, we might have a special event up here. We'll talk about that down the road. In fact, actually, we might remove this, but again, we'll talk about that down the road. Or we might actually collapse this into a function. Again, we'll talk about that down the road. And then if it was spawned into the world, which we default that to true, just based on how things work in Unreal Engine, what will happen is it will get the volume of the static mesh and take our base amount and multiply that together and give us our item amount. So if our base amount is 1 and the volume is, or the x is 1, the y is 1, the z is 1, the volume is 1, then, actually it's 1 cubed, then we have a base amount of 1 times 1, our item amount's 1. If this is 10, then our amount's 10. This is going to be useful for trees of different sizes, herb patches of different sizes. That's the only major difference in our resource master. What it comes down to in this section, because we'll take care of construction in section 4, is our food master. And our food master has this on-consumed event that we use our get hungry, or our character's hunger, I get hungry. We check, are they not full, so they're less than 100. And then if they aren't, we destroy the actor. We destroy the actor because we're spawning it in from the inventory. We have to spawn it in to get settings. If they are hungry, so they have less than 100 on fullness or on hunger here, we consume the food. So we update their hunger. We then discarded the item because, again, we've used it. And we destroy the actor we spawned in for this event. All right. And then we set up just dummy items. There is no real detail to go into. So next, let's look at our widget. We have our main widget, which stores all the child widgets. Of course, they're hidden behind the item details or each other. I did not mean to hide the close button. So in here is our actual inventory. We use slots that get spawned in. So if we go to our event graph here and close all other tabs, what happens is on event start, we set up our inventory, which checks, are we enabled? Because sometimes we do disenable the widget. Not the widget entire, just one panel, but this is just a good check anyway. What happens is we clear the children from our current inventory window. We get the number of slots that our inventory has and the data about those slots. So we start with a default of 10. We therefore then spawn in, based on that default, 10 slots. We set the index both in the slot itself and in the inventory. So when we create this array of slot data, we set the index. When we spawn in our inventory slot widget, we are confirming that index in the widget because we use that index over and over again. We then store this in that uniform grid panel that's in our designer. That's what's in the middle here. Sorry. That's the inventory panel, the uniform grid panel. And we take the amount we want per row and use that to determine, based on the index, where this should be placed. Now, if you're on a newer version of the engine, notice how far down this is. That's because as of 4.23 onwards, this has in row and in column. And if it does, you don't need this node or this node, but you do need this math. And you plug this math into the in row and column. We then add this to our inventory slots data that we have on our widget, and we update our slots, which means we set our slots if there's something in it. So if there's something in that inventory location, we set the slot to active, so we can click on it. If not, it's inactive, so we can't click on it. From there, we set up our menus, which is we just pass in the necessary references, which is the inventory actor and this widget, the inventory UI widget, to those sub-widgets. The only one we don't do that for directly this way is our details. We handle that slightly differently. And then we set an ability to listen for the input event known as inventory, which is defaulted out to I, but later in the series, we'll give the player the ability to change the keys, and if they change that key to B for some reason, they'll be able to use B to open and close their inventory, not just our little X up here. All right, we've already covered that. We've covered that. When we close the inventory, so for pressing I, it is this event here. For hitting the X, when I say X, I mean this X here. It's this button that we're hitting. We run an event in our player called close inventory, which basically just sets the game mode back to game mode only. We hide all our menus. Even if they're hidden, we want to just double check it. We want to set our panel back to active, because whenever we open a menu, we turn our inventory panel to inactive, so you can't open multiple menus. So basically, we're returning everything to the base state of when we opened it, and then we remove it from parent. This space is because we're going to have something to do with our equipment system here as well. When we click an item, so when the slot is active and we click it, that menu pops up. As I mentioned, we get a menu. Now that menu is going to be dynamically placed based on which widget we click. So we calculate where that's to be placed. Hey, abstraction, I'm not opening that one. Just because that math is meh to walk through. If you want to see it, actually I will open it. Here is the math just to double check what you have. Remember, we're using the item icon size. I guess not abstracting anymore. Oh, and the offset from the scroll box. Definitely not abstracting anymore. We update the inventory menu on its location. So if we open up that, we're setting the index, so pressing that in there. We're getting the item info that we need. So we need to know if it's what the consume text is, if it's use, eat, light on fire, crumple, what have you. We need to know if it's stackable, so therefore we can split it. And if it is stackable, does it have an amount more than one? All right, and after that, we set the menu to actually be visible. This just updates slots for when we split items, pick items up, all the other fun stuff. We do a little bit more than that in terms of the split stack. So all our menus get called up in this parent widget. To open the actual menu here, this use, discard, split, cancel, we have to click on our inventory slot here. So if we click on it, this is the update slot. If the slot is free, then there's nothing in there and we want the slot to be disabled. If it is not free, in other words, something is in it, we want to set it, get the icon, get the stack amount if we need that, and set details available. If we hover over it and we hover for more than 0.5 seconds, we check, can we actually get the item description? If we can, we get the little pop-up. If we click on it, we actually get rid of that because we set that to false. We also hide the information just to make life easier. We also move the menu. So we grab the menu, we move it. That's what we already looked at. And we disable the panel so we can't accidentally click other things. The menu itself allows us to do all the fun stuff in our inventory. So it allows us to use, eat, consume, what have you, discard, split, or close the menu. Cancel closes the menu. Use triggers whatever the use event is in the inventory. The inventory triggers the onConsumed event when it spawns the item in. The onConsumed event is overridden in each child. We then reset the inventory to be active and we hide this menu because, hey, we've done the thing. And now I have airbender quotes in my head. If we click on the discard, we check, do we have a single item? So is it stackable? And if it's stackable, are there more than one? If there's not more than one or it's not stackable, then we just discard a single item and reactivate the menu, the main inventory panel, that is. And again, this kind of closes. You'll notice that the closes right there. If we have more than one item, then we spawn our discard menu and disable our inventory panel and hide this menu. And then once that event is done, that menu closes out. And same for our split menu. We only activate this. There's no default sort of thing we can do if there's not multiple items or it's not stackable. All right. That takes us through our widgets. I'm not going to go through all of them, but the rough concept of how everything's set up, because this is a 20-minute review already. And we haven't done the big part, our inventory system itself. Let's just close all tabs to the right. So we've done data abstraction. Yeah, I know, I just saw I made a change there. We've done data abstraction with this because this is a private class and we have an implementer here. We set that's just a random note. We set the size of our inventory here, and we can use this in a polymorphic way to increase the size of our inventory. We'll talk about how to do that down the road if we want to. This updates those slots, and this is the event for triggering the use of items on spawning. So the main function really to get our inventory working, the part that we most definitely need, is to be able to add items to our inventory. We have two types of items. Those that can be stacked, even if it's just one item. When I say even if it's just one item, if we're just picking up one item. And those that can't be stacked, that are always just going to be by themselves. The non-stackable one, we find an empty slot. If one is found, then we add it to our inventory. We check, are there more than one non-stackable items? So if this cube here is set to 2, those are 2 non-stackable items. If I go to pick it up, I'm going to be over encumbered, but I now have 2 in my inventory. And they're not stacked on top of each other. As compared to, say, if I go to pick up this herb, which is 26, I'll have 25 in one column and 1 in the other, because my max stack size is 25. If we have multiple non-stackable items, we check. We increase our weight. Then we check, was there at least 2 items? If not, then we're done. We have nothing else to remain. If so, we decrease the amount we were trying to add, because we come in saying what amount we're trying to add right here. And we then call the function that we are currently in, because this is recursion, to add the amount. Once this finishes, we pass out that it's been successful, and it's done. If the item is stackable, and if I haven't gotten the edit in properly, I'm going to take this one slowly, especially towards the end, that is. We get our max stack size. We see if there's an available stack. By the way, in both cases, it doesn't matter what the index is, so the empty slot index or the index ref here, which should be stack index. If the bool is false here, even though we can't see the condition, it's inside this, then it doesn't matter what the index is because we use this bool first. So we find a stack, we set an index, or don't find a stack. This is really, really important. Oh my God, I can't trust how important this is. We set an index and we set a current amount local. We then do this add to stack, which is polymorphic. If we are creating a new stack, then we have this branch down here. If we're adding to an old stack, we have this branch up here. This middle bit is if either a new branch goes above the max amount, or is at the max amount, or if an old stack is above. Keyword is above for this one. It isn't above or at. Otherwise, the system would not work. So what we do is we pass in all the information we need. We check, did we actually find a stack? If not, then the index doesn't matter. We'll get a new index because we'll use the same thing we did for this single item. We're going to find an empty slot. If we are above our max amount, or at or above our, no, if we're above our max amount, then we just add our max amount and pass out any extra we have using this little check here. If we are under our max amount, we add item the normal way. We just pass in the amount we're adding and trigger our weight increase. I'm going to come back to this bit in a minute. I know it's going to go slow, but this is the easy bit. We're going to do the other easy bit. If when we're adding into an existing stack, if we are less than or equal to the max amount, then we just add in the amount we're trying to add to the current amount in that slot. And then add in our amount that we're trying to add into our encumbrance system. So if we're either over the amount we're trying to add, or in this case, if we're equal to or over the amount, if we're over our max amount, or in this case, at or over our max amount, because, technically, this will only fire if we're over our max amount. Okay, I misread it. We store the amount that we're going to have remaining left over. And we do this by taking our max stack size and taking from that what we need. So in this case, we know we're going to be over our max stack size. So we know there's going to be an extra amount stored in here. So let's say if we are adding into our stack 25, we have a max stack size of 23. We're adding in, we have a max stack size of 23. And we're adding, and we have a current stack of 23, and we're adding in 25. We only need 2. So we get that 2 here, and we take that from what we're trying to add in. So if we're trying to add in 25, that means we have 23 remaining to add in. And we pass that out over here. Likewise, if we have 23 in our stack, and again, with a max of 25, and we have 23 we're trying to add in, we still only just need 2. 2 from 23 is 21, so our remaining is 23. Our temp amount is really actually our weight amount. That is how much we're adding for our weight. So this is, in my example of 25 and 23, this is the 2. This is the 2 minus whatever we're trying to add in. We use the temp amount for our weight if it is an existing stack. If it is a new stack, then there's nothing there, so we just literally add the max in, and we pass out the amount remaining the other side. If we go back here, we then take the amount remaining and do a recursive call to the item master with the new amount, and we then just say we're successful. When this returns, it's done. Really, this shouldn't fire more than twice in terms of recursion. At least I don't think it should. Based on everything I've done, I've never seen it fire more than twice, but I've never added an item of, say, 200. And I'm pretty sure if I add an item of 200, it's 26. We're going to add another one of these. We're going to make this 260. All we're going to do is add a breakpoint here and see that this actually will fire more than once. I won't be able to pick up 260, by the way. That's 1. That's 2, 3, 4, 5, 6, 7, 8, 9, and the final one, 10. Oh, 11, 12. How did I get 12? Okay, I mean, it should have been 10. I might have miscounted when I was doing that, but it filled my inventory. And we still have, oh God, I can't move. I actually, 50, 100, 200. Huh. Okay. 250. I should just add it by 10. 250. There actually should be still 10 on the map, but I'm not so concerned about that right now because that really... Let's actually make this 360. I just want to make sure that it does kind of leave some on the map. I'll have to double check that down the road. You really shouldn't be adding items at large in anyway. So that takes us through our stacking. We'll double check this down the road. Oh. Yeah, I technically see what the issue is. We'll fix that later on. Don't worry. Again, if you want to add that many in, it relates to the return node here, just really quickly. I'll let you try to work out what it is. Hint, hint. So we've done that. Our discard, what we do is we check if there's actually an item there or not. And we check if the amount we're trying to discard is a valid amount. If it isn't, hey, nope, we're done. If it is all valid, then we run our event to store the item weight temporarily, because we're going to get rid of the item. We're not going to have a reference to its weight, potentially. So we store its weight locally. We then determine if the item is, we're checking the validity of the discard, we're checking if we're discarding the entire item stack, or if we're discarding part of it. If it's the entire stack, we clear the array element. If it's part of it, then we just remove that and reset the amount. We check, are we discarding the item? So is it a actual discarding of the item, or did the player consume the item? Because if they consumed it, we have to discard it from the inventory. If they've discarded it themselves, they're dropping it in the world, then we spawn the item into the world. If the players use it, we skip that spawning into the world. But either way, we trigger a weight decrease and we update our inventory. Okay, then we have our change slots, which we don't implement, so I'm not going to go through that one. We have our split stack here. So split stack, what we're doing is we are taking our stack information and we are checking, is there a free slot so we can split it into? If not, then we don't succeed. If there is, then we check, is it not oversplitting? So if we have 10 items, we can't split that into 11 and 2 somehow. And that it's actually harvestable. I'm pretty sure that meant to be stackable, but whatever. We can come back and clean this up later on. And then we check to see if we found a slot. If not, then we fail out again. If we do, a new slot that is, then we add the item to the new slot based on the amount we want to split by and adjust, or actually we adjust the old stack, removing the amount we want to split by, and then add a new item amount, create a new stack in the new slot based on the amount we want to add in. We update our inventory, and we don't change our weight, but we do re-trigger the inventory to set up so that all the icons properly display. Everything else is related to just determining if their availability, getting information, all the other stuff that supports everything we've looked at so far. This review video is about 30 minutes now, so I am going to call it here and say congratulations on making it this far. Yes, there are some little things we still need to clean up, as you saw, but this is getting the base system working. The cleanup happens when we start getting everything put together for this. That said, I hope you've enjoyed section 3 of this tutorial, and I look forward to seeing you, section 2 of this tutorial, and I look forward to seeing you in section 3, where we set up our equipment system. This project, the series, this tutorial have been brought to you by Patreon sponsors like Quad Menson, Rian, and Haynes. If you've enjoyed this series, make sure to hit that like button down below. And make sure to hit the subscribe and notify icon so you can join us when we start working on our equipment. We'll be doing our flashlight first, so we can just have something on screen to play with. All of that said, I look forward to seeing you in the next section. And don't worry about the fact that the collisions are off on that cube. These are tests. They're not meant to actually work properly for that. I'm not joking. They're actually not meant to. Not on the respawn. Other items will, and everything we set up is for the actual static meshes we're using. All right, all of that said, I'll see you in the next tutorial, and I hope that you have a wonderful day.